Hello everyone, welcome to day 6 of solving LeetCode problems until I'm hired by FAANG company. Today we're going to be solving 1579, remove max number of edges to keep graph fully traversable. Okay, so this is a hard problem. Alice and Bob have an undirected graph of n nodes and 3 types of edges. Type 1 can be traversed by Alice only, type 2 can be traversed by Bob only, and type 3 can be traversed by both Alice and Bob. Find the maximum number of edges you can remove so that after removing the edges, the graph can still be fully traversed by both Alice and Bob. Return the maximum number of edges you can remove, or return -1 if Alice and Bob cannot fully traverse the graph. Okay, so this does sound a little complicated. Let's look at example 1. We have 4 nodes here, n equals 4, and edges, well, we have a type 3 from 1 to 2. We have another type 3 from 2 to 3. So if we remove 2 edges here, 1, 1, 2, which would be this one, and 1, 1, 3, the graph will still be fully traversable by Alice and Bob. Okay, so now let's look at example 2. We have 1, 2, 3, and 4. Okay, so unfortunately, I was unable to get to the optimal solution. You can see that it says here, attempted. To efficiently solve this problem, we need a union find type structure. I did think about that during my initial attempt, but I was a little unsure of trying to use that solution.
Flashback.
They're not connected. We probably need a special data structure.
End of flashback.
We're going to go ahead and try to use a union find class. I still haven't fully gone through the solution myself, but just knowing that it uses the union find data structure, I believe that we can try to solve something like this. So let's just try to code the data structure first. So we need the init function. We're going to have self.parent, which is going to be equal to I for I in range of n. This is an argument that we're going to get from here. Self.rank is going to be the same for all of them. We need the find function, which we're going to check here. X is different. Self dot parents x is going to be equal to self dot parents x equals self dot parents turn x. Right, so we have basically the parent, or you might want to call the representative. Then we need def union. So P1 and P2 is going to be equal to self.findx, self.findY. Right, so we're simply going to check now if P1 equals P2, we're simply going to return, right? So if self.rank at P1 is greater than self.rank at P2, right, we're going to add the rank of P2 to P1. And we're going to assign the parent, right? So self parent and else, same thing, but the other way around. Now, to know if they are all fully connected, we could also have another variable, which would be components, which this would be equal simply to n. And well, if they have the same parent, we're simply not going to do anything. But if we did change the parent, that means that we have combined two different sets, right? So what we could do here is simply do self.components minus equal 1, then return. And once we do this, we can also have an additional function that could tell us if components is equal to 1. Components equals 1. And well, once we have the union find data structure, we can start coding this up, right? So we could do UF Bob UF equals union find n, then Alice UF equals union find n. Then we can simply start iterating. So for T, U, and V in edges, if T equals 3, we're going to join them. We're actually going to add here a return 0, here return 1, just to know what exactly happened, so that we can do here Bob UF dot union. So if this is false, then we're going to add a 1 to a res variable. Then if Alice UF dot union U and V, but actually this is going to be -1, -1, -1, and -1, res plus equal 1, elif t equals 2, this is for Bob, and then elif t equals 1, same thing for Alice. Then once we have this, we could do return res if Bob UF dot is combined and Alice UF dot is combined. Okay, so we self here, parents, all right, because this is a function, of course. Okay, so 3 cases accepted, and once we submit this, okay, but if we really want this to work for all of the test cases, I believe that it would be a little bit preferable if we would iterate again, right? So if t is equal to 2 and t is equal to 1, this way we are just considering first the 3's, which are the most useful, and we would only delete the least useful union finds connections afterwards. But first here, well, if we are first checking the third type, that means Bob and Alice are going to have it. So if this is 0, that means that it's already going to be 0 for Alice. So else, we're simply going to do Alice. Like if it is also not for Bob, then it's also not for Alice. So I believe this would be a better approach. Yeah, we need to delete that. Well, there it is. That took a little while. It was a little tough. Just probably need to keep practicing the union find data structure. But honestly, that was a very good approach.